Moving on to appreciation and depreciation. Appreciation just works the exact same way as compound interest, like I've just shown in the video before. So we're just increasing by a percentage over time, and depreciation is the opposite. It's going to decrease by a percentage over time. So I'll go over an example of each. So an example of appreciation. So example 1, the population of a city in 2010 is 150,000. The population is expected to rise by 1.6% every year until 2020. What will the population be to the nearest 1,000? So doing appreciation, so it's 100% plus the 1.6%. So that gives me 101.6%. And as a multiplier, that'll be 1.016. So then take 185,000, times it by the multiplier, and then do it to the power of how many times we're doing it. So we're going from 2010 up to 2020, so that's 10 years. So it's the power of 10. Okay, that gives me 216,823. And then what I want to do is just write it to the nearest 1,000, so 217,000. Right, example of depreciation. So this is going to vary just slightly, and it's only in the first step really. So just read the question first, would be good. The amount of frogs in the jungle decreased by 8% every year is currently 3,400. How long will it take for there to be less than 2,800? So when it's depreciation, the only difference is you take away the percentage instead of adding it on. Okay, so whereas before we would add 8%, this time we're going to take it away. So it's 92%, and then everything else is just the same. So 0.92. Then we're just going to take 3,400 and times it by 0.92. And you could do that to the power of how many times you're doing it. So if it was like 3 years, we could do it to the power of 3. And this question is slightly different because it wants how long is it going to be. So we need to do it until it gets to less than 2,800. So when I do it once, 3,400 times 0.92, that gives me 3,128. Okay, so gonna repeat the process for the second year using our new number 3,128, and that's going to give me quite close 2,878. So wants it to be less than 2,800, so we're just a little bit over. So we're going to do it one more time, which should be enough. That's going to give me 2,648. Okay, so how long is it going to take? It's going to take 3 years. Okay, because we did that 1, 2, 3. Did it 3 times. Example 3, where we're going to combine appreciation and depreciation. So example 3, the price of a house is 85,000. The price increases by 6% for 3 years. It then drops by 3% the following year. What will the value of the house be in 4 years? So 100%, and we're increasing by 6%, so plus 6% gives me 106%, which gives me 1.06. Then we're going to take 85,000 and we're going to times it by 1.06. And we're going to do it to the power of 3 because it's 3 years. And then that gives me 101,236. Okay. It's then going to drop by 3% the following year. So I've got 100%. Take away 3% gives me 97%. Which gives me 0.97. So that's 101,236 times 0.97. Only do it 1 year, so we don't need to write a power because it technically is the power of 1 already. And that is going to give me, and I've used my answer button on my calculator, so your answer might vary slightly if you've rounded it. I've done answer times 0.97, and that gives me 998,000, 199 pounds 27. I'm just going to leave it like that because there's no rounding there. So, part B, the house is then sold for £100,000. What is the percentage of profit from the original value of the house? So going to work out the profit first. So that's going to be 100,000, take away 85,000, which is 15,000. Then we're going to do 15,000 over, and it wants the original value. So it's over 85,000 times by 100 to get the percentage, which is 17.6%.